Thank you for watching this project help video for lesson 22. I will help you answer each question in the project by providing step-by-step example problems. A good strategy might be to pause the video after each example and then work the corresponding problem in your project. All right, so let's get started. All right, so problem background. Someone destroyed universe 3. The list of suspects are below along with some information on each. Use your knowledge of systems to determine who committed the crime. So we have set up the names of all our suspects here, Goku, Beerus, Champa, Jiren, and Whis, their power level and intelligence. Same problem as from lesson 21. But this time we're going to solve it using elimination, right? We're not going to solve it by graphing. We're going to solve using a algebraic method called elimination. All right, so the question 1 here asks, to eliminate the variable y, what steps can you take? So remember, what we're trying to do when we're solving using elimination is to get one of the coefficients in each of the equations to be equal but opposite. So if we want to eliminate the variable y, and in the top equation I see that we have a negative 3y, I would like to add these equations together so that y goes away, but look what happens if I do that right now. 2x plus 1x would be 3x. Minus 3y plus 1y would be negative 2y. That does not eliminate y. Somehow we need this to be a positive 3y, because if this was a negative 3y and this was positive 3y, when I added the equations together, y would eliminate. All right, so let's go ahead and read our options here. The first one says, let's multiply the first equation by negative 3 and then add them. Well, if I did that, right, the coefficient in front of y would be negative 3 times another negative 3, which would be positive 9. And then 9 plus 1 would be 10. Y didn't go away. All right, so this one isn't going to solve it. Let me zoom back out. All right, so it can't be the top one. Here we say add the equations together. Again, we said if we add them together, right, we don't eliminate y. What if we multiply the second equation by negative 2 and then add the equations? Let's see, if I multiply this by negative 2 down here, right, then I would have negative 2x minus 2y, negative 38. Then if I added the equations together, it looks like the x's would go away, but not the y's, right? Because we'd have a minus 3y here and a minus 2y here, and we'd end up with a negative 5y when I added the equations together. So although multiplying by negative 2 would eliminate x, the question is specifically saying what do I need to do to eliminate y? So this option's incorrect. Okay, this one says multiply the second equation by 3 and then add them. Okay, so if I went here and I multiplied the second equation by 3, that would end up giving us actually the result that we want. Because what would happen here is I'd multiply everything in the second equation by positive 3, excuse me. And then right here, when I distribute that 3, I would end up with a positive 3y here. And then when I added a minus 3y and a plus 3y, then the y would be eliminated. So in this case, this is our answer. Okay, so what is the power level of the suspect? Solve using elimination. And the power level, right, we defined as the variable x. It was in the first column of that table. All right, so what we should do here, and this is why question 1 asked you to eliminate y. If I want to solve for x, I need to eliminate the y, and then we'll be able to solve for the remaining equation that will only involve x. So let's go ahead and do that. Remember in question 1, we said we should multiply the second equation here by 3. All right, so I'm going to copy down the first one. I'm not going to change the first equation at all, so I'm still going to write 2x minus 3y is equal to 3. And then in the second equation here, I multiply everything by 3. So I'd end up with a 3x plus a 3y is equal to 19 times 3, which is 57. All right, now that I got the coefficients of y to be equal and opposite, when I add these two equations together, they're going to eliminate. That's why we call this method elimination. Notice that we have only an equation that involves one variable, in this case x. Now we can solve for x using inverse operation. So in this case, the 5 is being multiplied by x. To undo that, I divide both sides by 5. And we get that x is equal to 12. All right, so since this question is simply asking what is the power level of the suspect, they meant just solve for x. All right, so now we know that the power level of the suspect is 12. All right, and if we went back and looked at the table, you would see that we have two characters that have a power level of 12. All right, we have Champa and Wiss. All right, so based on the power level, which suspects can be eliminated? Okay, so here's our table. We just found out that the power level was 12. All right, so like we said, that's either Champa or Wiss have a power level of 12, but no one else does. So all the rest of these suspects, Goku, Beerus, and Jiren, can all be eliminated as suspects because they don't have a power level of 12. Yes, now question 4 says, well, let's find the intelligence of the guilty suspect. So they're saying let's solve for y now. Well, remember we eliminated we eliminated y in question 2, and we solved for x, and we got that x is equal to 12. Well, now that we know that x is 12, remember it corresponds to these two characters, we go back to either one of the original equations and substitute in the value for x. So it doesn't matter which equation I use, but you want to pick the one that looks the simplest, the one that involves the fewest calculations. So to me, that looks like the second one here would be the better option. Right, so I'm going to go ahead and replace the x with 12, right? That's what we mean substitute, replace. And I'd get that 12 plus y is equal to 19. Again, we have an equation with just one variable, so I can solve for it using inverse operations, and we're going to go ahead and subtract 12 from both sides. And we get now that y is equal to 7. And so this question here, they just want to know what the intelligence was. We can say that it is 7. And just since we have the table right here, we pretty much now know, right, who the suspect is, because we found out that x was 12. There it is. And that y was also 7. All right, so that means this character. All right, so now question 5 says, describe how you would identify the suspect who destroyed Universe 3, which was Champa, right, by eliminating the x instead of the y, and how does that change your answer? All right, so let's go back to our original equations here. I'm going to look at this slide. Let me erase some of this work here. And when we're solving a system of equations using elimination, it does not matter which variable we eliminate first. We can eliminate x. We can eliminate y. The way that I generally choose is whichever one looks easier to obtain. All right, and that depends on what you have to multiply by. You know, sometimes you just have to multiply one equation by one number, sometimes by both. If there's one that takes one step instead of two, I do the one with one step. In this case, if I would have eliminated x first instead of y, right, I would have been trying to get the x coefficients to be equal and opposite. So I would have multiplied the second equation here by -2. And then x would have gone away. And then we would have been able to solve for y, and I guarantee you we would have got the answer 7. And then when I substituted 7 back into one of the original equations here for y and solved for x, we'd get that x is 12. And so it doesn't matter which variable you eliminate first mathematically. Strategically, as a student, when you're solving these, you know, you want to pick the one that looks easier. In this case, both of them are equally easy. They both take one step. So just to show this to you, you know, if I multiply the second equation by -2, then I would end up with minus 2x minus 2y is equal to -38. Remember, even that 19 gets multiplied by -2. And then when I added it to the top equation, I would have had the x's eliminate, the x terms go away. Minus 3y and a minus 2y, they combine to be a minus 5y. And then here we'd have that positive 3 and a minus 38 is a negative 35. And then when I divide both sides by negative 5, we get y is equal to 7. So I just did that to demonstrate to you that it doesn't matter which variable we eliminate first, we're going to get the same answer. All right? So in this question, they want you to tell me what you would have to have multiplied by instead, and then to tell me that yes, you certainly do get the same answer.